Hello everyone. Today we're going to be reviewing together digitally all the review problems for quiz 2. We'll be taking a quiz tomorrow on C-VAR's Chebyshev's theorem, z-scores, and box and whisker plots. And since I'm not there to help you physically review for these problems, I figured I'd make a video of me going through each of the problems. So feel free to fast forward or rewind or pause and stop on the problems that you need to. The video is going to be a little bit longer and I apologize for that, but like I said, you don't have to watch the video. You can from start to finish. I mean, you can get to the problems that you need help with and then help each other while the sub's there. I don't think the sub knows any of the math, so you're going to have to help each other and rely on each other in this video. So we are going to be for sure taking the quiz tomorrow on C-VAR's, Chebyshev's theorem, z-scores, and box and whisker plots, and percentiles. So if you have any questions, even after watching this video and doing the problems in class, try to find me Tuesday morning. And yeah, with that, let's get started and let's try some problems.
So tomorrow when you get to the quiz, you are going to get on the left-hand side this green formula cheat sheet for quiz 2, and then also in order to do the z-score problems, you're going to get that purple table that tells you how to look up the percentages once you've found the z-score. So you're going to have these two sheets for the quiz, so make sure you're referencing these. I've also uploaded these digitally onto your Google Classroom, so if you want to look up these PDFs so that you can see what formulas you're going to have to use, or if you can't read them from this slide, then you may have to look up the PDFs on Classroom. And I think that the purple tables should be on the counter by the calculators, and of course you're going to need a graphing calculator for some of the problems, so make sure you grab a graphing calculator and one of those purple z-score tables for your problems today. Okay. Problem number 1. Mrs. Littlefield's husband, William, is trying to plan for purchasing a new Chevy truck within the next 5 years. He's been looking at different Chevy dealerships to see who has the most consistent prices. Cooper in Mandan, Cooper's average pre-owned Chevy truck sells for $42,997 with a standard deviation of $2,450. The Bismarck Chevy dealership, Pucklick's average pre-owned Chevy truck sells for $31,996 with a standard deviation of 3,102. Which dealership has more reliable prices? So this is actually a real life problem between Mrs. Littlefield and her husband, William. We've been looking at Chevy trucks and we are actually trying to buy one within the next 5 years. And these prices, you guys, are not just made up. I actually went onto their websites for the month of November to see what their prices were, and I typed them all into my calculator, and Cooper's average is 42,000 and Pucklick's average is actually 31,000, and these are the true standard deviations too. So which dealership has more reliable prices? So we can try to, in 5 years, stick with one dealership. So hint, use C-VAR formula. Well, C-VAR's, or coefficient of variance formula, is the standard deviation divided by the mean times 100. Remember, you want to use the C-VAR formula when you're comparing variability between two different sets of data. So because we're looking at two totally different dealerships with standard deviation and mean, we're going to have to use this formula twice. So first let's look at Cooper. So if we take the standard deviation divided by the mean for Cooper, that's 2,450 divided by 42,997, and take that times 100, we should get a percentage of 5.69 for Cooper's C-VAR. If we do it for Pucklick, we take the standard deviation of 3,102 divided by 31,996 times 100 to get us a percent of 9.96 for Pucklick's C-VAR. So based on these two percentages, the question was, which dealership is more reliable or has more reliable prices? And the answer would be that Cooper has more reliable prices that don't fluctuate as much. So with that knowledge, I'm going to take it back to my husband so that we can continue looking at Cooper's trucks because they're more accurate in what we can afford. Okay, number 2. Legacy students spend an average of 9.5 hours per week of free time in their school schedules. If the standard deviation is 1.35 hours, what is the minimum percentage of students that have anywhere from 11.525 hours to 7.475 hours of free time? Hint, use Chebyshev's theorem. Okay, so because they did not tell us that this distribution was normal, we have to use Chebyshev's theorem because we don't have a normal bell curve, as you can tell from the picture. So our average for hours of free time in your schedule at Legacy is 9.5. And they're asking us, what is the minimum percent of students that have anywhere from 7.475 to 11.525. So the question is, what is the percent of students that fall in between here at Legacy? So Chebyshev's theorem is 1 minus 1 over k squared is going to give me that percentage. But I was not given a k in the problem. I was given a range. So remember, we have to use another formula called k is equal to the value minus the mean divided by the standard deviation. And that's how we developed the z-score. Sorry, that's a bad k here. I'll rewrite it. So k is equal to the value minus the mean divided by standard deviation. And remember, k is how many standard deviations we are away on the left and right hand side from the mean. So before we can use this formula to find what the percentages of students that spend anywhere from 11.5 roughly, or sorry, from 7.25 to 11.5, we have to find what k is, or how many standard deviations we are away from the mean. When we're using this formula, k is equal to value minus mean over standard deviation, in the context of Chebyshev, we can pick either of the two values. So I always pick the positive value, and you guys know that. So k is going to be equal to 11.525 minus the mean is 9.5 all over the standard deviation of 1.35. So if I plug into my calculator 11.525 minus 9.5 divided by 1.35, I should get k is equal to 1.5. So we're 1.5 standard deviations away from the mean. And if you look on that green chart posted to Google Classroom, 1.5 was not a traditional standard deviation in the table for k for Chebyshev, which means that I'm going to have to plug it into this theorem. So we have 1 minus 1 over k is now 1.5 squared equal to the percent. So what you're going to plug into your calculator is 1.5 squared, and then you're going to take 1 minus that, and 1.5 squared was 2.25, so it's going to be 1 divided by 2.25, and then 1 minus that answer. So you should get 0.5, if you plug that into your calculator, right, it should be 0.55555 repeating. So that percentage then is 55.56% of students spend anywhere between 7.5 to 11.5 hours of free time in a given week at Legacy. So about half of you. Huh, that's good to know. Okay. Example number 3. Books in the library are found to have an average length of 350 pages with standard deviation of 100. Assume that the data is normally distributed. Okay, what percentage, there's two parts to this question, and when we know that there's a normal bell curve, we're going to probably have to find a z-score and use the z purple table. Okay, so what is the percentage of books that have less than 80 pages? So I like drawing it on the picture. So I have 350 as my average with a standard deviation of 100, but I'm probably over here at 80 pages. And so they're asking, what is the percentage of books that have less than 80 pages? So anywhere between books that have less than 80 pages. So what is that percent? That is the question. So before I can look up the percentage on my purple table, I have to find my z-score. So that's going to be the value of 80 minus the mean of 350 all over the standard deviation of 100. So if I take 80 minus 350, I should get a negative 270 divided by 100. That means that my z-score is a negative 2.70. Okay, so negative 2.7. So you go to your purple chart, we're looking for a negative 2.70 is that number right there, which should be 0.0035 if you can see that. Oops, here I'll try to erase this for you. So when we looked that up, we got a percentage of 0.0035. but we have to move the decimal over, so that means that it's actually 0.35%. And so when they say what percentage of books have less than 80 pages, less than 1% have less than 80 pages at the library. So that's my answer for that one. So now let's move on to part B. Okay, books in the library. Part B. What is the percentage of books that have more than 415 pages? So my average again was 350. We're asking about 415, but this time we're asking what percentage of them fall more than, so that's to the right of this guy. So what percent of books there? So we still have to find the z-score first before we can look it up in the purple table. Okay, so z is going to be equal to 415 minus 350, all divided by our standard deviation of 100. If we take 415 minus 350, we get 65 divided by 100. So that means that my z-score then is 0.65. So when we go to the purple chart, we're going to be looking up 0.6. That's this guy right here. Here, I'll use a highlighter. 0.6, so it's this row, but we need to look for the one that is 0.5. So that's this column, so that's going to be 0.7422. So remember that number, 0.7422. But remember the purple chart, when we look up the purple chart, that gives me the percentage of this to the left of that score of 415. So if I want to find the percentage that falls to the right of my value of 415, that means that I have to take 1 minus 0.7422. So in my calculator, I have to take 1 minus 0.7422. And we should have gotten 0.2578, which means that 25.78% of the books have more than 415 pages. So 25.78.